Alright, here we have my second attempt for the first kinetics quiz. The first attempt, I had a little error here. I added these two together instead of subtracting. So I had 186.5 instead of what I'm assuming is the correct answer of 180.6. So yeah, so basically did the same thing as before. Same question for number one, just different numbers. Head of the rocket, that's launched upward. It's the height of the rocket when the end of the thrust, which is here. This is our y0, so this is where we have no more thrust, and if we do a free body diagram, all we would have is gravity pulling it down. So I know we're also assuming constant acceleration before we had thrust, which is why, it was accelerating upwards, but we don't have that anymore. So everything is going down, or acceleration is going down, and then velocity is falling and such. But yeah, and everything that way is our positive y direction. Same thing. Velocity is also initial at the moment. Initially positive, but yes, this direction is positive for everything, or considered positive for everything. So, y0, which is this guy, the moment that it stops moving upwards, or the thrust kicks out, so it's just gravity pulling it down. We have and then we're assuming a constant acceleration with no extra wind resistance, so that allows us to use kinematic equations. We know the y0 is 29.6 feet, and that the rocket lands 8 seconds later. So, a rocket also freely fell to the ground after reaching its maximum height. So, we are looking for the initial speed of the rocket after the end of the thrust. So, we have y0, time, and we know the final height as well. So, this kinematic equation right here that involves position, initial velocity, time, and acceleration. We have all but one variable in this. We just don't have the initial velocity. So we can plug and chug numbers in and move some stuff over to the left side. Make sure we do it correctly. 2 times 32.2 minus 29.6 divided by 8. You get 125.1 feet per second. So very simple, only need one kinematic equation. Question number 2, same as up top, just different numbers. Rocket is launched upward, height is 82.9 feet when the thrust cuts out, so we have our y0 again, our initial y, and then we also know it has a velocity of 128.2 feet per second. And then, of course, we have gravity as well. That's a constant. So we're just looking for the maximum height of the rocket. And as I explained in my first video, this is a position graph for y of just the height. So y-axis, we have y, or the height in feet, and we have t in seconds. And so, as you can see here, this is technically it doesn't start until up here because of y0, but you get the general gist of it. But up at the top here, we know that velocity is the derivative of the position function with respect to time. So we know that when the derivative, or the slope of this, is equal to 0, that means the velocity is equal to 0, and that is the max height right there. So we have to figure out the time, which is 3.98 seconds, but use that using this kinematic equation, again, assuming constant acceleration. V equals initial velocity, or the initial velocity plus the acceleration times time. And we're looking for V equals 0, so 0 equals our initial velocity of 128.2 minus 32.2 t. So we find that t equals 3.98 seconds. I'll double check that to make sure we don't have any errors. Yeah, 3.98 seconds. Then we can plug that guy over into this kinematic equation. Same as before, but we have the initial height, initial velocity, the time, then we have the acceleration, and of course the time. So at that point, it is just plug and chug. And I will double check that to make sure that everything is correct. 28.2, yeah, times 3.98. Plus 82.9. Hold up. Actually getting... Oh. Initial velocity of 128.2 times 3.98. Then you have 32.2 divided by 2 times 3.98 squared. What is that? I'm actually getting quite a bit of a different answer. Yes, 338.1 feet. Let's see, comparing our answer to this guy. V0 plus AT, 128.2 divided by 32.2. Times that. Divided by 2. Yeah, I'm getting a different answer than I originally did, so I guess it's good that I checked my work again. Just trying to see where I could have possibly gone wrong, but we say maybe I just forgot to square the 3.98 times 2 times 3. Yeah, I have no idea how I got that original number. It's kind of confusing. Just kind of going over everything as well over here. Make sure everything is all set. Um, 28.2 squared. Oh, I see. I initially only included those two in it, and that gives me 593.3, and I did not subtract anything from that part. So yeah, it's good to find the error. So 338.1 is what that comes out to be about. 510.4. This is -255.2, which is actually exactly half of that. Interesting enough. So I guess positive 2.9 plus 510.4 minus 255.2. Yeah, about 338.1. And yeah, those are final answers. 338.1 feet and 125.1 feet per second.